In this video we will study about the Newton's laws of motion. There are basically three laws are there. First one is law of inertia, or we can say Newton's first law of motion. In this law it is said that if any object is at rest, then it will be remain at rest, and if it is in motion, then it will remain in motion, or if it is moving in a particular direction, then it will remain to move in that particular direction only, until and unless some external force is applied to change its state. So this was the Newton's first law of motion, in which we have also named it as law of inertia, because inertia is basically taking place there. So if any object is at rest, then it will remain at rest, and if any object is in motion, then it will remain in motion until and unless an external force is applied on it. Some examples of this particular law can be given by like this. When a horse running so fast and it suddenly stops, the rider throws forward, because earlier rider was also moving, and horse is stopped at the particular position. Then the lower part of the rider, which is in the direct contact with the horse, will stop, but the upper part, which is in motion, will come forward, and the rider will fall forward. Similarly, if there is a tree and fruits are hanging on it, and if we shake the branch, then what will happen? Fruits will be in rest, and they wants to be at rest due to the inertia of rest, and branch is shaken. That's why fruit will be detached from the branch, and they will come downwards by the gravity. So this is the law of inertia, and this is also known as the qualitative law. This is also known as the qualitative law. It also defines the force. According to Newton's first law of motion, a body is at rest or in uniform motion will remain at rest until external force is applied. So we can say that force is an external agency which changes or tends to the state of rest or uniform motion in a straight line. Means we can give the definition of force by using the law of inertia. Similarly, the second law of motion, it is also known as, in some books, law of momentum. What is law of momentum? According to this law, the force applied on an object is directly proportional to rate of change in momentum. So what is rate of in physics? Basically, rate of means upon time, and change in momentum, that is delta p upon t. When I remove the proportionality symbol, a constant is applied there, that is k, and the value of k is 1. Putting k as 1, I will get it as F is equals to delta p upon t. What is delta p? It is change in momentum, means p final minus p initial upon time. And what is p final? It is mv minus mu upon t. I can take m as common, and I will get it as F is equals to m v minus u upon t. V minus u upon t, this quantity is known as acceleration, so F is equals to ma. So by using the second law, I can derive F is equals to ma, and hence it is known as, I can find the quantity of the force here. So this law is also known as quantitative law. This is the second law of motion given by the Newton, and some theoretical questions can be arise by this topic, like why the cricket player lowers his hand while catching the ball. So according to second law, F is equals to delta P upon T, means I can say that force is inversely proportional to time. If the time is increased, then force will be decreased. So when a player catches a ball, he lowers his hand, and when he lowers his hand, the time of contact will increase, and when the time of contact will increase, then force will be automatically decreased, and hence he will not be injured. So in any question, if time is reduced to increase the force or time is increased to reduce the force, then it can be related to the quantitative law, or I can say the second law of the motion. Some more examples. If a person falling from a certain height receives more injuries when he fall on a cemented floor than when he fall on a heap of sand. See, when he fall on heap of sand, then what will happen? The time of contact will increase, and when the time of contact will increase, the force will be decreased, and the person will get less injuries. We can also derive F is equals to ma in this manner, that P vector is equals to mv vector, where P is the momentum and v is the velocity of the particle. And we know that the force, or let it differentiating both side, so it will be dp by dt will be equal to differentiation of mv. M is constant, so it can be taken out, and it will be equal to dv by dt. What is dv by dt? It is the differentiation of velocity with respect to time, and it is acceleration, ma vector, and here it is dp by dt. What is ma? It is force, F vector. Hence, rate of change in momentum is equal to the force applied. That was the second law of motion. The force is directly proportional to rate of change in momentum. We can also derive it like this. Now, for the third law of motion, that is known as action-reaction law. Action-reaction law. What is action-reaction law? According to this law, if action is applied on an object, then there will be equal and opposite reaction. Means if we apply force on an object, then it will apply force on us in the opposite direction, and the applied force will be equal to that force which we have applied. Suppose there is a wall, and this is a person, and he is pushing the wall. This is the wall, and person is pushing the wall. Then wall will push back the person with the same force the person has applied on the wall. But in daily life we do not see like this, that the wall is pushing the person back. Why? Because there is some friction between the person's leg and the floor. If the person is on roller skates, then if he is pushing the wall, then what will happen? Wall will push him back, and we can see easily that person is going back. So every action has an equal and opposite reaction. Similarly, when there is a balloon, this is a balloon, and air is filled in it. When air is released from this side, then balloon will move in this direction. So air is coming outwards, so it is action, and due to the reaction, balloon is moving in this direction. This is also occurred in the motion of rocket, that when the gases comes out, this is action, gases are coming out, this is action, and rocket is moving upward, that is reaction. So every action has equal and opposite reaction. We can also see like this, if there is an object A, and it is going in this direction, then when it will strike B, then what will happen? The force on A due to B will be in this direction, and the force on B due to A will be in this direction. Both are vector quantities, So I can write it as in magnitude they both will be equal and in the opposite direction. So FAB vector will be equal to minus of FBA vector. So again, one force is action and the second force is reaction, and they both are equal in magnitude. That's why equal is applied here, and minus sign shows that they both are acting in the opposite direction. This is known as action reaction law. Similarly, if on a floor there is a box, kept it there, and box is applying gravity in the downward direction, or we can say the weight of box is in the downward direction, the gravity is attracting it with the force mg, then there must be a reaction force r which is applied by this surface, or I can say by this table in the opposite direction, due to which the box will remain here only. If reaction force is not there, then what will happen, this box will break the table and will go downward because only one force mg is acting. But if box is placed here and it is not going downward, then we can say that there must be some force acting in the opposite direction which is cancelling this mg force. So here I can say r is equals to mg, due to which the box is kept in the rest position. We can also see it like this. When we move forward, then we try to push the floor in the backward direction. We are trying to push the floor in the backward direction, which means that we are applying force in the opposite direction, due to which a reaction is occurring on our body and we are moving in this direction. So this is the another example for action reaction law. One more thing is there, that is Newton's second law is the real law of motion. Why we used to say this? Because by using the Newton's second law we can prove Newton's law of motion first and Newton's law of motion third by using the second law of only. So we are proving the first law by using the second law first. So the second law is said that F is equals to delta P upon T, means force is equal to the rate of change in momentum or directly proportional to rate of change in momentum. If external force is not applied, then F is equals to 0 and it will be equal to delta P upon delta T. By cross multiplication I can write it as delta P is equals to 0. What is delta P? This is rate of change in momentum. Hence m v minus u is equals to 0. Taking m towards this side, we will get v minus u is equals to 0 or v is equals to u. So this we can say that the object is moving with the constant velocity, means the initial velocity is same as the final velocity. So if the object is initially at rest, then finally it will be at rest, and if the object is moving with the particular speed or the object is in motion, then it will remain in motion if external force is not applied. Now we will prove the third law by using the second law. See, if there are two objects A and B there and they are isolated from the external world, B means external factors will not affect them, and we are also assuming that there is no external force, then what will be force of B on A, or I can say force on A due to B will be equal to rate of change of momentum in A, and force on B will be equal to change in momentum of B. So force on B due to A will be equal to change in momentum of B with respect to time. Adding both equations, we will get it as FAB vector plus FBA vector is equals to d by dt of this much. See, external force is not applied. When external force is not applied, then I can say that if external force is not applied, then F is equals to dp by dt, and force is not applied, then dp by dt will be equal to 0. So this whole will be equal to 0. Then taking this towards the right side, I will get it as FAB is equals to minus of FBA, which means that both forces are equal, but negative sign shows that they both are acting in the opposite direction. So this is the action reaction pair, and hence by using the second law, this one was the second law, by using the second law we have proved the third law. So I can say that Newton's second law of motion is the real law of motion.